Okay guys, let's take a look at some of our long division problems here. And the directions say we need to use long division, so we will. But it also says to state the quotient q of x and the remainder r of x, which are themselves polynomial expressions, but we still want to state the quotient and the remainder here. And so taking a look at number one, since we are using long division, let's go ahead and get started here. We need to recognize first of all that the thing being divided is the dividend and goes inside of our array. So we have x squared plus 8x plus 15. And then on the outside of the array here we have our divisor polynomial here. So x plus 5. So just to kind of reiterate what it is that we're doing here. What we're doing is we are taking some, I suppose, f of x here, and we are dividing it by some divisor polynomial. So in this case you can see that this is like our f of x here being divided by x plus 5. But what we're going to get is some quotient here that we refer to as q of x since it's a polynomial, and we would also say plus any remainder that we get here we represent with r of x, and that's over the thing that we were dividing by in the first place. So let's go ahead and take a look at this and go through our steps for long division here, which can be summed up using this. We say, does McDonald's sell cheeseburgers? It's kind of a little mnemonic that I use here, but basically division, multiplication, subtraction, okay, carry down, and then begin again. So carry down, referring to carrying down a term, and then starting again with our division here. So we can follow this little algorithm here that would take us through division, starting with step number one. Basically, I want to know how many times does x plus 5 go into this? Well, we'll start with our first terms here. We'll basically ask how many times does x go into x squared. Now remember, we can answer this question just by saying what can I take times this leading term to get this leading term. And in this case, I can think of only one thing I can take, like times x to get x squared, and that's x. So I'm going to put my x up here, and one thing I want you to remember is, of course, I would put my x to the first up here in my quotient over my x's to the first in my dividend here. So this x up here, what that does is it takes care of our division for us. So now next up on the list is, we're going to multiply this by everything over here on the left. X times x is x squared, and x times 5, of course, is a positive 5x. So the thing that's pretty important about this step is that we are going to subtract everything in parentheses here, and our responsibility will be to rewrite this as addition by distributing the negative through the parentheses here. And so what we would get is adding now positive x squared and negative x squared canceling out. And 8x to the first minus 5x to the first here would be 3x to the first. So we've done our multiplication, our subtraction. Now we'll carry down here our next term, which is this positive 15, and we'll just start up again, except for this time when we ask how many times does x go into this, we're going to say, looking at our leading term here, 3x. And of course we would ask, what can I take times x to get 3x? Well, that would be a 3. You'll notice that we put this constant 3 above the constant 15 here. But let's go ahead and do our multiplication then. 3 times x is 3x. 3 times 5, it's a positive 15 here. And of course we would subtract everything. And so again, rewriting this as addition, we say add the opposite. This will become a negative. This will become a negative here. And so we get this to cancel, we get this to cancel. And the interesting thing that happens here is that we see that this leftover part here, this is of course our remainder. So our remainder, with respect to this, if you have no remainder, then we tend not to write our remainder up here, but the instructions said state the quotient q of x and the remainder. And so what I'm going to do up here is I'm going to write this is x plus 3 plus our remainder, okay, over the thing we were dividing by in the first place, which is this x plus 5. So to write out what we get more formally here, we see that our quotient was x plus 3, and we say plus our remainder here, which was really just 0 over x plus 5. And that's reflected over here. We see our quotient, the x plus 3 part, q of x. And then we have our remainder here, r of x, which is just 0 over the dividend, or the divisor, excuse me, the thing we're dividing by. So long division, it's pretty formal, you know, you go through the steps. Let's take a look at, say, number 5 then here. Number 5, I want to notice that we are taking a third degree, this time, polynomial divided by a first degree polynomial. And then we'll get some commentary on our results here in terms of the degree of our quotient. So we have 6x to the third plus 7x squared plus 12x minus 5. And on the outside here, we'll put 3x minus 1. So let's go ahead and take a look at this here. We'll start with our division. What could we take times 3x to get 6x cubed? Well, we'd have to take it times a 2 and an x squared. So that 2x squared, be mindful that it goes above our x squared terms here. Let's go ahead and take 2x and multiply it by everything over here in our divisor. So 2x squared times 3x is 6x to the third. 2x squared times a negative 1, of course, is just negative 2x squared. So again, let's subtract everybody here and rewrite this as add the opposite. So this will become negative, this will actually become positive. We'll just add these where we get cancellation here, and we also get 7x squared plus 2x squared coming out to be 9x squared. So after we've done our subtraction, we'll want to carry down our 12x here, and then we'll just start up again, except this time asking what could I take times 3x to get 9x squared. So 3 times 3 would be our 9. Of course, x times x would be x squared. So we'll put a plus 3x here to the first above our 12x to the first. Go ahead and do our multiplication. 3x times 3x is 9x squared. 3x times a negative 1 is negative 3x. And again, we're going to subtract all this off and rewrite this as adding the opposite. And so adding these, what we end up with is 0 here, 0x squared. We get 15 total x's to the first, and we say that this is minus 5. So lastly, we'd say how many times does 3x go into 15x? Well, we could take 3x times what to get 15x? We would take it times a 5. So putting 5, which is a constant, above our negative 5 here in the dividend, which is also a constant, let's go ahead and do our multiplication. We get 5 times 3x is 15x here, and then 5 times a negative 1 is a negative 5. So the interesting thing that happens here is we actually get left with no remainder on this one as well. And so we'd say no remainder. We could write that as plus 0 over the thing we were dividing by, which is 3x minus 1. But again, more formally, we would say that our quotient, q of x, was 2x squared plus 3x plus 5. This is our q of x part. And then we say plus the remainder here is 0 over 3x minus 1. This right here is our remainder part. Okay. So if you ever get a non-zero remainder, we would write it just the same as we do here, except for you just wouldn't have 0 over this. And typically when we have a 0 for a remainder anyways, we tend not to write it. We just write the quotient is what we get for an answer. But I want to make sure that we are writing the remainders in here just to kind of form that habit. Okay. So looking at this next two, these are long division as well, but you're going to see that we've kind of represented them differently. So very quickly here with number 9, I'm not going to proceed to do this, but what I want to do is I want to bring up the fact that remember that a rational expression or a fraction here represents the top being divided by the bottom. So to set something like this up would just be x plus 3, and then on the inside we have 2x cubed plus 7x squared plus 9x minus 20. Now, one thing I wanted to do was after this last one here, notice that we took a third degree thing and we divided a first degree thing out of it. And so you could look at it as this, you know, if I had third degree, then really what we're going to be doing is by dividing a first degree out of the third degree, we're going to get left with just something that is one less in degree than what we started with, or in this case, a second degree. And looking back at this first problem here, we took a second degree divided by a first degree, and we ended up with a first degree. So the way we can look at division is kind of like saying, well, if our polynomial that we're dividing is of nth degree, and we're dividing out something of mth degree, then what we would get is n minus m in term of degree on the top. In other words, you would just take the degree of the thing you were dividing and subtract off the degree of the thing you were dividing by, and that will be the degree of our quotient here. And so rightfully we could say that this being a third degree thing divided by a first degree thing here, I want you to recognize that when you do this, you're going to end up with a second degree thing here, and so you'll have a polynomial starting above your 7x squared. Now, I will take a look at number 15 with this here for a couple of reasons. One, to kind of continue the conversation we were just having, and two, because we actually have a quadratic divisor, second degree, and what we're doing is we're dividing 18x to the fourth plus 9x cubed, so we say plus 9x cubed plus 3x squared. The only problem with this is that I tend to have a lot of people forget that you need to put in these two for place value. That's like me saying, you know, for instance here, 1002 divided by 4 is really 3 because, you know, these zeros don't really count because they don't represent anything anyways, and so it's 12 over 4. Well, we all know that because these zeros are in here for a reason, because of place value, you can't just neglect them. And so because we were missing some x to the first terms here and a constant term, we do need to fill those in. So kind of a conjecture before we start. I notice we're taking a fourth degree, okay, fourth degree, and we're dividing by a second degree. So a quartic divided by a quadratic. And so what we should expect to get here is a second degree. And the reason why is because we divided 2 of our degrees out of the top here by using the bottom there. At least, you know, if the top is 4th degree and we divide 2 of those degrees out, there would be 2 left over. And so taking a look at this, let's go ahead and take a look here. we've got how many times 3x squared would go into 18x to the fourth here? Well, what could we take times 3 to get 18? What could we take times x squared to get x to the fourth? By my recollection, it would have to be a 6, and it would have to be an x squared. So already we're seeing that we're getting left with the second degree thing here. Let's go ahead and carry out our multiplication. So 6x squared times all of this, well, definitely we're going to get 18x to the fourth beyond a doubt. But 6x to the second times a positive 1, well, that would be positive 6x to the second. So instantly, I want you to notice something here. I've got a 9x cubed and a 6x squared underneath. There's a problem here, and that problem is essentially this. What you're going to have to do is you're going to have to make sure that you line your place values up correctly. So that is to say, when you take 6x squared times 1 and you get 6x squared, that's going to need to be stacked underneath your x squared term here, just because of place value. And so let's go ahead and rewrite this as addition of the opposite here. So these would both become negative in here. And looking at this, we'd say, well, this would be gone. In terms of how many x's squared we have, well, I know I have negative 3x's squared, but the thing I want to bring up here is this. Because I had no x's to the third, you could look at this as just being carried down here and becoming 9x to the third, okay? Or you could look at this as saying that we just literally had no x's to the third here, and so we were combining 9x to the third with no x's to the third, and we just get left with 9x to the third. So let's, just like we do with division, let's go ahead and carry down our next term here. Even though it's a 0, and we'll start up again, we would say, well, how many times would 3x squared go into 9x cubed? And so let's take a look at this. What could I take times 3x squared to get 9x cubed? We take it times a 3 and an x. And so our 3x times everything over here, of course, 3x times 3x squared is 9x cubed. We were aiming for that. But 3x times the 1 here, that's really 3x. And so being mindful this time, we're actually going to stack that underneath our x's to the first. And so again, let's rewrite this as adding the opposite here. So this will become a negative 3x. And so what we end up with here is this. These cancel. We'll go ahead and carry down our negative 3x squared here. 0x plus negative 3x is negative 3x. And then we still need to carry down our 0 and start again. So 3x squared times what would be a negative 3x squared? Well, the only thing I can think of here is a negative 1. And so negative 1 times this 3x squared, we get a negative 3x squared. Negative 1 times a positive 1 is actually a negative 1. Interestingly, this is the first one we've seen so far in this video where we're actually going to end up with a remainder, which is totally okay. And so what we get here is, whoops, let's switch back to red, negative 3x plus 1. This right here I know is my remainder, and let me talk a little bit about why, because what I have here is a first degree, which a second degree thing would never fit into a first degree thing. And another way to look at this is I cannot think of something besides having a negative exponent that I can take times 3x to the second and get negative 3x to the first. So what that's going to mean is that this is our remainder here. So as we write the remainder, recall that up here next to our quotient, which is this part right here, the answer to the division part, and we would say, okay, well, this is all over 3x squared plus 1, since that's what we were dividing by, but our remainder, I'll even put it in red, was negative 3x plus 1. And so formally here, we would say that we get 6x squared plus 3x minus 1 with a remainder of negative 3x plus 1 over 3x squared plus 1. And so just to label these, again, this is our quotient, okay? And this thing up here, this polynomial on top here, this is our remainder polynomial. Cheers.